All right, so as I was saying, we are going to just quickly do the calculations for the graph. So I'm just going to make one up quickly. Let's say if x is equal to 1 over, let's do 2 over x plus 1 minus 4. Right, that is the original graph. And say the question is saying you need to draw this graph and you need to draw the inverse. All right, now we can find the equation of the inverse by swapping x and y around like we did in the previous example, and then making y the subject. But the point I'm trying to make is that you don't actually always have to do that. You don't have to find the equation of the inverse and do all the calculations a second time. For this, I'm hoping that we all can see that this is a hyperbola, right? So this is a hyperbola. We're going to have two asymptotes. Remember that we have an x asymptote that we by looking at the denominator, and then the y asymptote is the one that is just the q value. So, apologies. The vertical asymptote, vertical is that one, all right? So that's x asymptote is going to be x equals -1. The horizontal asymptote, right, that one, is going to be y equals -4. Now, like I said here at the top, you are going to swap the x and values of the points of the original graph to get points of the inverse, but you are going to do the same thing with the asymptotes. So if f of x is that, then I'm going to be able to find all the information of the inverse without even finding the equation of that graph. So if the vertical asymptote and the horizontal asymptote, right, if we're looking at these two asymptotes, the x asymptote of the original is -1. This means that y asymptote of the inverse is going to be -1. So the asymptotes basically spur around, right? So if the vertical asymptote of the original is x equals -1, then you swap that x with a y, and that will give you the horizontal asymptote. You can do the same thing with the y asymptote. The y asymptote is -4 of the original, so for inverse, the x asymptote is going to -4. Right? So you can swap the x and the y. So basically you have your two asymptotes. If you just swap x and y around, that will give you the two asymptotes of your inverse. Okay, now when we are finding hyperbola, when we're trying to draw it, we need to find the x-intercept and the y-intercept. And remember, not all hyperbolas will have both x and a y-intercept, but we just need to do the calculation to see. So for the x-intercept, we need to make y equal to 0. So remember, this is whole thing equal to 0 now. So I'm going to say 0 is equal to 2 over x plus 1 minus 4. Right, so we're making y equal to 0. I'm going to move that -4 over. I'm going to say positive 4 is 2 over x plus 1. Like that. Then we are going to say 4 times x plus 1 is equal to 2. So 4x plus 4 is equal to 2. 4x is -2. So x is -1/2, -2 over 4. So x-intercept is -1/2, 0. That. Okay, so that's good. So now the x-intercept, the original graph, is going to become the y-intercept of the inverse, because to get a point on the inverse, all we need to do is swap up x and y around. If I have a -1/2, 0, all I have to do is swap those two around, and that will give me the point 0, -1/2. Which we know, if you have a point for your x value is 0, that is the y-intercept. So the x-intercept of the original graph becomes the y-intercept of the inverse. X and Y surround. Okay, if we're finding Y-intercept of the original graph, remember that means it must make X equal to 0. Okay, so in this equation, we're going to say that Y is equal to, and remember, we don't actually have to show the substitution. I'm just showing it for the sake of the example. So 2 over X plus 1, which is now 0 plus 1 minus 4. So this is 2 over 1, which is 2 minus 4, which is then negative 2. So that means that Y-intercept points to 0, negative 2. Now, if we want to use this point to find a point on the inverse, all we need to do is swap X and Y around. So when we are swapping 0, negative 2 around, we're going to get negative 0, which is the X-intercept of the inverse. Sorry, negative 2, 0. Okay, if you needed to, I'm not sure, I would have to check, but remember with a hyperbola, often you need to find another point. So let's say if we're subbing in X equals 1, find another point on this graph, we're going to make X equal 1 in that equation. Right, so I'm using this equation, and in the place of 0, I'm just putting a 1. So we're making X equal to 1. So this is 2 over 2, which is 1 minus 4. Which is negative 3. So that means that the point 1, negative 3 will lie on the graph, meaning that the point, if we swap it around, negative 3, 1 will lie on the graph of the inverse. Okay, so what I'm trying to show you guys is that you're not going to have to do double work ever. If you are asked to draw a graph and its inverse, you just do the calculations for the original graph and then take all of the information that you're getting, all of the asymptotes, all of the points, and you just swap them around to get that same information of the inverse. All right. Then the last bit of information that is important, I can actually do it at the bottom here. Remember when we're talking about domain and range, and this is something that you were supposed to copy down on Friday. Remember that the domain is the set of all X values of a graph, and then the range is the set of all Y values of a graph. Now, again, when we're working with main and range, we're working with X and Y. And like I said many times before, when you are going from the original graph to the inverse, you swap X and Y around. So the domain of the original graph will give you the range of the inverse and vice versa, right? So if you are saying, for example, the domain of the original X is an element of real numbers, then the range of the inverse is going to be Y, an element of real numbers. The same thing happens when we are going from range to, yeah, so the range of the original will also be the domain of the inverse. So, and I'm running out of space here. I'm just going to squeeze it in. The range of original is equal to domain of inverse. For example, if the range of your original graph was, let's say it was Y is an element of real numbers, but y cannot be equal to 2. So say, for example, it was as a hyperbola with an asymptote y equal 2, then that would be the range, right? Y can be any real number, but just not 2, just not where the asymptote is. Then the domain of the inverse is going to have these same values, but we're just going to swap x and y. So instead of saying y element of real numbers, y not equal to 2, we're going to say x is an element of real numbers, but x cannot be equal to 2. Because if we think about this example that we did up at the top, if y equals 2 was an asymptote of the original graph, x equals 2 is going to be an asymptote of the inverse. Okay. So guys, it's actually quite simple to work with inverses. If you remember, the most important thing, which is underlined here, that x and y swap around. Okay, in all cases, when you are finding the equation of the inverse, when you are drawing the function, when you are working with domain and range, all right, in all scenarios, x and y swap around. And I don't have a textbook at home, so I'm just quickly checking what it says on the grade classroom in terms of homework for this section. So if you can just give me a second, I just want to get to that quickly. Okay, I am going to send you guys some homework for tomorrow. I will be back at school tomorrow, so we are going to mark this all tomorrow. So please make sure that you do it. So if you are going to, this is in your textbook, exercise 1.2 on page 47. I would like you to numbers 1 and 3, and then exercise 2.3 on page 51, if you could do numbers 2 and 4. Okay, so that is your homework for tomorrow. Thank you guys. If you have any questions about this lesson, if there was anything that you didn't understand, please feel free to send me an email. I will be reachable on my emails today, and I will try to get to you as quickly as possible. Have a lovely day and happy Valentine's Day.